Okay, this is Chapter 3, Part 3. We left off last time getting into the nuts and bolts of the classic experimental design. Let's clarify that with an example. This visual that you see here was taken from the textbook, and it's describing an actual study that was done where the hypothesis was that the idea that if teachers expect students to do well in class and perform well on tests, etc., that the students will do better if the teachers expect that, if they think that the kids can do well, that they will. So that's the hypothesis that they're testing. Now, the way they designed this experiment to test that, to see if it's true, is they got a group of students and they randomly divided them into two groups. This first part here on the left, you see it says random assignment. So they divided up the students randomly into two groups. There's the group on the top, that's the experimental group, and the group on the bottom, which is the control group. Now, presumably these groups ended up having kids that were the same. One group should have been very similar in the makeup of kids compared to the other groups. The similar numbers of males and female students. They all should be the same age because they're like from the same class, the same year, and other characteristics. Maybe, for example, like race or religion or something. These kids are randomly divided up, so you should get roughly equal numbers of different kinds of students in each group, especially if your sample size is large. If you get a really big sample of people and divide them up randomly, those two groups should be equivalent, which is a term that we use in this experimental research. You want the groups to be as equivalent, the same as possible. So the only thing that they did differently in the experimental group compared to the control group was the teachers were told, the teachers who were in charge of the experimental group kids, they were told that these kids that you've been assigned to are really sharp, that they're quick learners. They use this term spurters, I guess, quick meaning quick learners. They can pick up stuff really quickly. They were told that even though it wasn't true. The kids were exactly the same mix of kids as in the control group, but they wanted to test the idea that if you believe that the kids had all this potential, that it actually would make the kids do better. You see that quite often in experiments, that there's a little bit of dishonesty or deception, which sometimes raises ethical questions, but you do that to see if that, and this is a term that you see in experimental research, manipulation, that you manipulate the situations to see if that manipulation makes a difference. In this case, putting into the teachers' minds the belief that the students had tremendous potential. So they had these teachers teach the kids for 8 months in both groups. So the kids got the same experience with one difference. The experimental group teachers were told that the kids were awesome or were great learners. And then at the end of 8 months, they tested them again. I should back up just a little bit because that T1 on the left-hand side, that means at time 1, at the beginning of the study, they tested both groups of kids to see how good of students they were. And if I recall, they found that these groups were very similar in their average test scores at that beginning of the study. So they teach them for 8 months, and then they test them again at T2, that's time 2. They test them again to see if the kids in the experimental group, if they ended up getting higher test scores and higher test scores than the kids in the control group. And so see, this experimental design is a powerful way to try to test hypotheses, because if the two groups were treated exactly the same, except for one difference, the teachers in the experimental group were told that their students were fantastic learners. That was the only difference. Otherwise, it's the same. If the kids from the experimental group end up with in the end with higher scores, then you can pretty solidly conclude that the reason why the scores got higher is because the teachers had such high expectations for the students. So that's the power of the experimental design, is that you neutralize any differences between the two groups. You make them exactly the same so that there's, except for one thing, you sort of isolate and identify one difference. And if the two groups turn out differently, it must be due to that one single difference. That's the logic of experimental design. And that's the main thing I want you to get from this chapter, when we're talking about experiments, is that it's really good at identifying what is causing what. Let's move to the next slide here. Threats to internal validity. If you recall, by internal validity, we mean, was the experiment done properly so that your results in the lab are valid, are solid, are true. And here they say threats to that. So these are negative things that can go wrong with an experiment. And remember, you always, for every research design that we cover this semester, you want to jot down a couple of positive things about this type of design, strengths of this type of design, but also a couple negatives, because that's very likely to show up on quizzes, pros and cons, because every method has strengths and weaknesses. And here they talk about 4 possible weaknesses, although I would say that they're not necessarily weaker than other methods, but there's still problems that you can run into. This first one here that I've highlighted is history. And what they mean by that is you have other non-experimental events have caused the changes that are observed. So let's bring it home to this example. If you had something happen to the kids along the way, this 8 months that they're being taught by teachers, and in the experimental group, the teachers believe that they're really awesome students who have great potential. If something else, just by a fluke or accident, intervened that, say, for example, boosted those kids' scores, let's just say, I don't know, it could be 100 different things. But let's say that you just by luck happen to get 4 or 5 students in that class who were just awesome students just by luck, and that they were really good at helping all the other students and motivating the other students and being positive and encouraging them. And it was just something an accident that happened. And as a result of this handful of students who really were just good at helping and kind of in creating enthusiasm for what was being taught, that it resulted in the grades and the test scores getting better. And so in that case, it wouldn't be the teacher's expectations that led to improved test scores. It was just something that kind of accidentally happened, a small group of kids that made the difference. So that's what they mean by history, is some event, something unusual that the researchers didn't plan on, sort of intervened and ended up making the difference. And then you would end up, if you said, well, if you looked at the results and said these kids got better test scores, so therefore it must be the teacher's expectations, you would be wrong in this case, because it was actually this small group of enthusiastic kids that really kind of turned things around and made things better in the classroom. So these threats to internal validity, they're things that go wrong that kind of undermine your results or lead you to a misinterpretation where you come up with an answer, a conclusion that's not right, it's not valid. Okay, that's history. The next one, subjects may become sensitized to testing. What they mean by a testing effect is that it's common knowledge that the more that you take a test, the better you become at it, because you kind of learn strategies of how to take it better, how to manage your time, and you just learn tricks and that kind of stuff. You get used to something, you get better at it. And so that's, it's true for testing. And so it could be that the students got better from time 1 to time 2 because they took the same test twice, and the second time they got better at it because they had some practice. They took it the first time, and so now they're a little more familiar with the test. They did better the second time. So if the students in the experimental group ended up improving their testing because they got used to the test the first time, you might conclude, well, look, at the students got better, so it's because of the teachers, expecting a lot out of the students. The teachers believe that the students could really learn a lot. You might say that that's the reason why they did better, but actually the truth is that they just got better because they were taking a test the second time, and they were used to it the second time, so that's why they did better. See, here you can see the importance of a control group, because the control group should get better at taking tests too. They take the test 2 times, just like the kids in the experimental group. But so if their scores go up, that wouldn't be a surprise because they've got practice and they're getting better. But for the experimental group, for you to conclude that teacher expectancies, expectations matter, then the test scores should go up even more for the experimental group kids compared to the control kids. Yes, they might go up in the control group because they're getting used to the testing, but that's also true for the experimental group. But if the experimental group improves even more than the control group kids, well, then you could conclude it's because the teachers had real strong positive expectations, right? So that's the power of having a control group, is it kind of neutralizes, it gives you something to compare against to make sure that it's not something else that's going on that's leading to the improved test scores. So you always need, I'll say it right here in case I forget to say it later, you always need to have a control group as well as an experimental group. If you don't have a control group and you only have a group that you give the treatment to, then that you do the thing with here, tell the teachers that these kids are really awesome. That's if you ever run across a study that has an experimental group and doesn't have a control group, that's a bad study. It's just not good. You have to have both to be able to know for sure what's going on. You have to have the experimental group and the control group. Now this next problem, maturation. People change over time in any event. That's called maturation. So what they mean by that is, using the same example of this study, the study goes on for quite a long time, 8 months. That's what a school year is, like 9 months. And then you take out summer, so it's basically almost a school year. Well, in a full school year's worth of time, students might get better on a test just because they're now 8 months older. Kids, mature and grow and develop quickly. And part of their growing is that they get naturally smarter and more mature and more able to understand things, and that could translate to better test scores. We know that older kids tend to do better on the same test than younger kids because they're more mature and more developed, smarter. And so what this maturation means is that people naturally might get better over time, and it may not be the teacher's expectations that lead the kids to have better test scores. It might be that the kids are just naturally maturing and getting a little bit older and doing better on the test score. So how do you rule out this maturation thing? How do you rule out that as an explanation? Again, you compare the scores with the scores of the control group kids, because they're growing and maturing and getting older too. And so if the scores go up in the control group, but they go up more in the experimental group, then you conclude it looks like teachers' expectations make a difference, because these kids in the experimental group, they improved even more than the control group kids improved. So yeah, maybe there's some maturation going on there, some natural positive development, but the experimental kids went even beyond that. So it must be teachers' positive expectations that made a difference. See, so again, you have the control group to compare against. Now, this next one, selection. Non-random selection could explain differences. If you've got a bad researcher who's either doesn't know what they're doing or maybe they're dishonest, they might want this to be true, or they want to prove this is true, that if teachers have really positive attitudes and believe that you can do it, that you can. So a researcher may be invested in that and want it to be true. So they may, if they're dishonest, they may not assign the kids randomly to the two groups, but they'll tend to put the best students in the experimental group. So the test scores get higher because you stack that experimental group with the best kids, with the best students, right? So that's kind of a cheating if you're doing it intentionally, but even if you do it unintentionally, it's going to screw up your results. You need to have two groups that are equivalent, where the performance of the average student is the same in both groups. You don't want to stack, the experimental group with a certain type of kid. That's going to screw up your results. So that's how come we emphasize random assignment, randomization as they call it, where you're not hand-picking which kid goes into which group. It's a random process, so there's no selection, and no tampering is another way of thinking of it. So then you can trust your results. If it's truly randomization into the two groups, experimental and control group, then you can better trust your results. Then you should have valid results. So that's just, and it's something that people can do wrong, but it's not a weakness of experimental method, because generally researchers do know that they need to do random assignment, and they do that, and so you don't have that problem. And finally, this next one here is a problem, but it's not a weakness of experimental methods, because it's a problem with lots of different types of research. This ambiguity about the direction of causal influence, because sometimes the temporal sequence is unclear. Well, so what they're saying is that if you don't always know what changed first and what changed second in an experiment. In this experiment, it's pretty clear what's the direction of the relationship, what's happening first, because the teachers are told right up front at the beginning of the study, hey, in the experimental group, hey, these students are really sharp, they have a lot of potential, they're learning really quickly. So the teachers have that in their heads in the beginning. And then if you see high student test scores by these kids in the experimental group at the end of the 8 months, and so you see those test scores go up, well, we know that it must be that the teacher's expectations had an influence on the kids' scores, and not the other way around. The kids' scores at time 2, at the end of the study, are not going to influence what the teacher was thinking 8 months before, right? You don't have things now influencing stuff that happened in the past. It doesn't work that way. Cause and effect work forward in time. So it must be, if there's a connection, if the experimental group turned out with higher scores, it must be that the teacher's expectations had an influence on the test scores, and not the high test scores, making the teachers think, oh, these students really are sharp and really have a lot of potential, right? You can't go that way, because the teachers got those ideas put in their head in the beginning. Okay, but so this was a well done study that way. But if a study's not done carefully, then you may not know what's coming first, right? The good scores, or whatever you did to make the good scores, right? To try to make the good scores better. So you just have to make sure in an experiment like this that they call it a treatment, or the thing that you do different to the experimental group. They call that a treatment, or they call it intervention, call it a manipulation. You need to make sure that manipulation, that telling the teachers these students are awesome, that happens before whatever it is that you are studying, their test scores, right? How their test scores end up at the end. So you just have to make sure and design your study that way. Then you won't have this problem with, well, which way is the causal arrow going? What's causing what? You won't have that problem. Let's move to the next slide. Okay, let's see. Well, we're almost 20 minutes into this video segment, so let's go ahead stop here. And in the next segments, the fourth part to this chapter, we'll get into these remaining designs. See you then.